Hello, my differential equation class student. Today we continue work, and today I talk about 4.5 section and question. We did Laplace transformation before for good enough function, for continuous function. We know what happened with product function. But what happened if you have piecewise function? First, we need to remember you need step function. Okay, it will be u with index a function depend c, or it will be u c minus a function is function who is equals 0 if t less than a and equal 1 if t greater or equal a. If you're looking for graph, it will be, this is our t rectangular coordinate system. Let's go, this is point A. And graph, I'm use some different color. For example, red. We have something is equal 0. And for t equal a, here we have open point. And this will be a. And now we're ready for some theorem 1 who tell us if you have piecewise function ft and Laplace transformation for this function exist and equal Laplace transformation from u c minus a for this piece f c minus a equal exponential function minus ac power f to the c. And this is equivalent inverse Laplace transformation from e to the minus ac f to the c will be u c minus a f c minus a. Okay, how it's work? We can some example. First I clear my table. Just a moment. I think you remember definition, all right. Our unit step function, and here we have. Taking some example. I need to evaluate inverse Laplace transformation from e to the minus a c power divided by c to the third. What we have here? If you remember, inverse Laplace transformation for function 1 over c to the cube, it will be 1/2 c square. Use this fact and use our theorem number 1. We have this as function is u to the c minus a one half c minus a square. Or we can write this is equal, which will be more clear understood what we have. This is equal. If c less than a, we have exactly 0. If c greatest or equal a, you have 1 half c minus a, c minus a. Maybe I'm alright. It's more correctly. C minus a square. Something like there. If it's your point A, here we have some parabola. Before parabola, you have 0. This will be your graph. Okay. See second example. Before I'm finished clearing. Guys, about your last quiz. No bad, great, and I finished grading and put all your grade today after this lecture. But problem, one of you write only answer. It's okay, it's great, but next time if I have only answer, I'm not grading. Second, some of you forgot about deadline. I give you whole day until midnight. Please, next time will be more accurately and use deadline. Okay, great. And now we're ready for looking for second example. Let's go our function. Let's see, equal 0 if c less than 3 and c square if c greatest or equal 3. Now I need found function will be this part is equal to square. Now I take it f c equal c plus 3 to the square. What I choose this function because f from c minus 3 it will be exactly c square, exactly part what we need. Okay, but now ft we will write ft distributed will be c square plus 6t plus 9, and this mean big Fs, it's Laplace transformation for function ft, it will be s cube and numerical is 2 factorial, this means 2 plus 6 times 1 over s square, or I write 6 over s square, and 9 is will be only 9 over s. And this situation is Laplace transformation for my function gt. Use our theorem we know it will be Laplace transformation for my function step function u c minus 3 f c minus 3, and this is exponential function e to the negative 3s multiplied by big Fs. We know it will be 2 to the s cube plus 6 to the s square plus 9 to the s. Okay. One more example. let's go our function. It's a little bit different. We know step function is unit step function is before you have 0, and before some number you have 0, after you have 1. What happened if we need opposite? This means if your function ft is equal cosine 2t, whereas t change from 0 until 2 pi, and then equals 0 if t greatest or equal to pi. This means my function ft is, first I need non-zero, but if I'm right, just a moment, how I can write u c minus 2 pi, it will be until 2 pi I have 1, after 2 pi I have 0, but I need opposite. Okay, what we're doing? We have 1 minus u c minus 2 pi, and then multiplied by cosine 2t. Okay, here I clear. I can distribute, and I have here, I have cosine 2t minus u c minus 2 pi. Here I prepare my function. This means I write cosine twice t minus 2 pi. Trigonometrical function is periodically function. This means I can add 2 pi, subtract 2 pi, is nothing changed. Looking here, but now I'm prepare my function ft for Laplace transformation. What we have here, L from ft will be Laplace transformation from cosine 2t, we did before a lot of time, and Laplace transformation for product, unit step function for cosine. Okay, it gives me minus e to the negative 2 pi s, and Laplace transformation from cosine 2t minus 2 pi. But because it's periodically function, we skip, and we have only cosine 2t. Okay, go back. This means use Laplace transformation. We have s over s squared plus 4 minus e to the minus pi s over s squared plus 4. If you want, you can write this s over s squared plus 4, 1 minus pi s. Oh, I forgot 2 here because it's 2 pi s, you see? We did Laplace transformation for this kind of function too. Doing some example. This means solve some differential equation. Let's go our function. Just a moment, I clear here. Okay, I have second derivative x plus 4x equal ft, whereas ft is exactly function from example before. This means ft equal cosine 2t if t between 0 and 2 pi and equals 0. Sorry, guys. Sorry. У меня класс. And 0 if t greatest, t greatest or equal to pi. This means our function is exactly from example what we solved before. And use Laplace transformation for this equation. We have s square x to the s plus 4 x to the s equal s 1 minus e to the negative 2 pi s over s square plus 4. Factoring and divide, and we have x to the s. Here we have s square plus 4 and separate little bit. This means x to the s. It will be s over s square plus 4 square minus e to the minus 2 pi s over s square plus 4 to the square. And now we try use inverse Laplace transformation. And first, if we have inverse Laplace transformation from s over s square plus 4 square, how you remember? It will be 1/4 t sine 2t. Use this fact. Your function, okay, I'm clear, I need clear a little bit. Especially here. Just a moment. Okay. We need to use inverse Laplace transformation for this function xs, and remember what is inverse Laplace transformation for this part. Okay, this is s. Inverse Laplace transformation for x to the s will be 1/4 t sine 2t sine 2t, and because here we have exponential, this means exponential step function t minus 2 pi and 1/4 t minus 2 pi. Here I need multiply by sine 2t minus 2 pi. Okay. Remember, sine function is periodically function and period is 2 pi. We can write finally our function will be 1/4 t sine 2t if t less than 2 pi and 1/2 pi sine 2t if t greater or equal to pi. This means how we solving our problem. One more type of function, how we not studied before. What happened if you have periodic function? No, we work with periodic functions, sine and cosine, but what happened if it's more complicated, something like this? Okay, it's not continuous, for example. Just a moment. Okay, here we have theorem number two. Let function f periodic with period p with piecewise continuous for t greater than 0, and okay, this means ft periodic with period period, oops, period pi, p, not pi, sorry, continue, and L for ft equals some big Fs. Then Fs equal 1 over 1 minus e to the power ps integral from 0 to p e to the minus st ft dt. Looks scary, but we try use this theorem and you can see it's no problem. First example. I'm trying use my function will be this kind of. From 0 to a, it will be 1. From a to a, it's negative 1. But here is will be open point, here is will be closed point. This is open. Then again 1, and then I guess negative 1. How you can see, this is periodically function. Period here, p, is 2a. This means smallest interval when we have your function covered all possible solution. Okay, now we're done with our theorem. This means our example, p is 2a. Okay, now we build our Laplace transformation for this function. I think I need clear here. And it will be f to the s 1 over 1 minus e to the negative 2a s, because p is 2a, integral from 0 to 2a e to the negative st f t dt. But how you remember, this integral is separate to a. Separate for two integrals. From 0 to a, your function equal 1, and from a to 2a, your function equal negative 1. This means we continue. It will be 1 over 1 minus e to the negative 2as. Here integral from 0 to a e to the minus st dt minus integral from a to 2a e to the minus st dt. Okay? Counting each integral separately, we have 1 over 1 minus, this is multiplicator, integral from first is exponential function, same exponential function, only 1 over coefficient exponent, this means minus 1 over s e to the minus st from 0 to a. Here we have same problem, this means plus 1 over s e to the minus s c from a to 2a. Practically we're done with Laplace transformation, we only spend time for simplifying. Okay, it will be 1 minus 2as. Here is 1 over s, and plug. This will be minus e to the minus as. If you plug in 0, it will be 1, negative 1. And you need subtract, this means plus 1. Here you have plus e to the minus 2as and minus e to the minus as. Okay? Simple rewrite, we have, this is full square, and it will be 1 minus e to the minus as square s, and remember about coefficient, I'm factoring e to the minus as 1 plus e to the minus as square, and this part cancel it, and final answer here, a little bit clear here, clear my theorem. Remember we have some function ft, and Laplace transformation for this function is our ft is 1 minus e to the minus as s 1 plus e to the minus as. Okay, if you want, you can little bit play with power and rewrite this function as like 1 over s hyperbolic tangent from a s over 2. Okay. Who remember definition hyperbolic function? The next example, oops, here. I think this function we need to remember because it's very useful formula. Let's see something, one more example. Let's go, we have function who is, this is graph. Let's go, this is a, this is 2a, 4a, 6a, and continue. And we have some triangle here. And consider how we can use Laplace transformation for this function. Looking here, this means from 0 to a, if t is from 0 to a, your function ft equal t, and if your t from a to a, your function is ft is equal a minus, I think it's 2a minus t. But what is interesting for this function? If you take a derivative, it will be exactly, and periodically, I'm taking it only for one period. If you take a derivative, this function, this is your fc function. What happened if you take a derivative? From 0 to a, it will be 1. This is a. From a to 2a, it will be negative 1. 1. Then it's continue 1, negative 1. This means exactly function from our first example. This is derivative of prime t. And now I can use, first I use definition for derivative and how it's relation between. I can write, okay, here I'm clear, can write my Laplace transformation for function example 2, it will be Laplace transformation for function example 1 divided by s. This means Laplace from this ft, it will be fs over s. And it will be 1 over s square. Oh, if you use hyperbolic tangent, as over 2. Taking one more example. Okay, clear now table. Check here, check all of them, and clear all of them, okay. Let's say sometimes it takes so much time, okay. Let's go, our function is from question number 16 from your book. What happened if your function is ft maybe I'm doing 6 first. Number 6 and number 16. What is our plan for today? Number 6. Your Laplace transformation give us function who is s e to the minus s over s square plus b square. This means here you have exponential function multiplied by s over s square plus b square. Okay, what you have here? Inverse Laplace transformation for function s over s square plus p square give you cosine pt, right? Cosine pt, because pi is our coefficient s, and here we work. What we have in a inverse Laplace transformation for our fs. Here you have piecewise function, and it will be 0 if t is less than 1. Where is come this 1? 1 is coefficient exponential function. Power is exponential function. It will be here. We have -1. This means opposite is will be 1. And equal minus cosine pi t for t greatest or equal 1. This means we have this kind of until 1. Okay, I write this different color. Let's go, this is 1. Until 1 we have 0. And then after 1 you have this kind of function. Oops. Okay.